Why does the night sky look like a static, twinkling dome when it is actually a vanishing act? You are standing in your backyard on a crisp, moonless night, tilting your head back toward a permanent ceiling of stars. If you could zoom out past the moon, past the rings of Saturn, and beyond the final stars of the Milky Way, you would face a reality that defies every human intuition. This is the observable universe. It is a sphere of light and matter 93 billion light-years wide, centered exactly on your current position. Physics contains a glitch here. Even though we see galaxies at the edge of that 93 billion light-year bubble, we can never reach them. Space is stretching apart faster than the speed of light. Consequently, 94% of the galaxies visible in our telescopes today are already physically unreachable. Their light reaches us for now, but they are effectively gone. We are watching the ghosts of a universe that has moved beyond our grasp, and eventually their light will vanish from our sky forever. For most of human history, we believed the stars were just a few miles away. A century ago, the greatest minds in science assumed the Milky Way was the entire universe. That changed in April 1920 during the Great Debate at the National Academy of Sciences. Two astronomers, Harlow Shapley and Heber Curtis, argued over whether the faint, fuzzy spirals in our telescopes were small clouds of gas nearby or distant island universes. This clash of scales determined the size of reality. In 1923, Edwin Hubble used a massive telescope at Mount Wilson to find a pulsing star in the Andromeda Nebula. He did the math and realized that star was nearly 1 million light-years away. In one afternoon, the universe exploded in size. We weren't living in the only house in the woods. We were living in one house in a city of trillions. As our telescopes improved, the mystery deepened. In the late 1920s, Hubble Investo Slipher noticed that light from distant galaxies was stretched out and shifting toward the red end of the spectrum. This redshift meant everything in the deep sky was screaming away from us. Imagine drawing two dots on a balloon and then blowing it up. The dots aren't walking, the rubber between them is expanding. This is the behavior of the cosmic fabric. Space is not a cold, empty void but a dynamic, stretching material because there is so much distance between us and the furthest galaxies. The stretching adds up, eventually. The distance grows so fast that even a beam of light can never bridge the gap. This creates a cosmic border called the particle horizon. Think of it like standing on a pier at night, watching a ship sail into a thick fog. The ship's lantern dims as it moves further into the mist until the light vanishes. The ship is still there, and the sailors are still looking at their own stars. But for you on the pier, the ship has ceased to exist. In our universe, that mist is 46 billion light-years away in every direction. It is the literal end of where information can reach us. We are looking at the edge of the reachable world. Anything beyond that line moves away so quickly that no radio wave or photon of light will ever reach Earth, even if we wait for a trillion years. To understand this scale, consider the moon. It takes light about 1 second to travel from the moon to your eyes, meaning you see it as it was 1 second ago. The sun is 8 minutes away. The stars you see with your naked eye are dozens or hundreds of years in the past. But the edge of the observable universe is different. The light we see from the furthest reaches has been traveling for nearly 14 billion years. That journey began when the universe was a hot soup of particles, long before the Earth existed. We are looking at the beginning of time, because the universe expanded while that light was traveling. Those distant objects are now tens of billions of light-years further away than they look. In 1965, Arno Penzias and Robert Wilson were working with a giant horn-shaped antenna in New Jersey. They heard a persistent, low-level hiss coming from every direction. They initially blamed bird droppings on the antenna or interference from the city. Instead, they had stumbled upon the wall of the observable universe. That hiss was the cosmic microwave background radiation, the fading heat of the Big Bang. It is the oldest light in existence and marks the boundary of our vision. It is the ultimate background wallpaper of the cosmos. We can see it and measure it, but we can never go past it. It represents a hard limit on what humans can ever know about the space we inhabit. The 93 billion light-year bubble we see is likely just a tiny fraction of what actually exists. In 1981, physicist Alan Guth proposed the theory of cosmic inflation. He suggested that in the first trillionth of a second after the Big Bang, the universe expanded so violently that it smoothed out the fabric of space. If Guth is correct, the part we can't see could be millions of times larger than the part we can. It might even be infinite. We are like ants living on a single leaf in a forest that spans a continent, unaware that the forest exists because our horizon ends at the edge of the branch. This brings us to a haunting realization about our future. In 1998, teams led by Adam Rees discovered that the expansion of the universe is accelerating. A mysterious force called dark energy is pushing everything apart faster every day. This means the fog on the pier is closing in. Over billions of years, more galaxies will cross the point of no return. They will slip over the horizon and disappear from our view. Eventually, the Milky Way will be the only thing left in a dark, empty sky. Any civilizations born in the distant future will look up and see nothing but blackness, never knowing that a trillion other galaxies once filled their heavens. This limit on our vision defines our place in the grand design. We live in a brief, golden window of cosmic history where we can still see the evidence of our origins. We can see the light from the first stars and hear the echo of the beginning. We are the first generation of humans to understand exactly how large the arena is, and we may be among the last to see the rest of the players. The universe is a vast, unfolding story. We have been given a front row seat to a show that is slowly, quietly being moved out of reach. When you look back up at those stars tonight, remember that you aren't just looking at lights in the sky. You are looking at the edge of a vanishing empire. The vast majority of the universe is already unreachable, and the gap is widening by the second. We are passengers on a small blue island, surrounded by a sea of space that is growing so fast it is literally deleting the rest of existence from our future. The sheer scale of what lies beyond our sight is a reminder of how rare this moment of clarity is. We are a tiny part of a whole that is too big to ever fully see, suspended in a bubble of light that is slowly fading into the eternal dark. Can a room truly be empty if the walls themselves are growing? To understand why the universe is vanishing, we must stop thinking of space as a cold, hollow void and instead view it as a piece of dark, elastic fabric. In 1912, at the Lowell Observatory in Arizona, Vesto Slipher began noticing something strange about the light coming from distant clouds of gas. When he looked through his telescope, the light from these objects wasn't the color he expected. It was shifted toward the red end of the spectrum. In the world of physics, light stretches when an object moves away from you, turning redder as the waves get longer. Slipher discovered that almost every distant object he tracked was racing away from Earth at incredible speeds. He had just found the first evidence that our entire reality is stretching like a rubber band. By 1929, Edwin Hubble took these findings to the Mount Wilson Observatory in California and attached a specific, world-changing number to the mystery. He noticed a perfect pattern where the farther away a galaxy was, the faster it appeared to be moving. This wasn't just a few stars drifting apart. Hubble realized that the space between galaxies is actually growing. If you imagine a loaf of raisin bread rising in an oven, the raisins aren't moving because they have tiny engines. They move apart because the dough between them is expanding. Hubble's law proved that the universe has no fixed center. Every point in space is pushing away from every other point, all at once in every direction. This brings us to the Hubble constant, a concept that sounds like it should be impossible. According to the 1998 measurements from Adam Rees, space is expanding at a rate of 73 kilometers per second for every megaparsec of distance. A megaparsec is a massive unit of length totaling 3 million light-years. To put that in perspective, if you look at a galaxy 3 million light-years away, the space between us is growing by 73 kilometers every single second. If you look at a galaxy twice as far away, that gap is growing by 146 kilometers per second. The further you look, the faster the treadmill of space moves. Here is where the physics of the universe breaks your intuition. Because the expansion rate adds up over vast distances, there is a point in the deep sky where the space between us and a distant galaxy is growing faster than the speed of light. You might remember from school that nothing can travel faster than light, which remains true for objects moving through space like a rocket or a laser beam. However, there is no speed limit for space itself. The fabric of the universe can stretch as fast as it wants. This creates a cosmic treadmill where a galaxy tries to send its light toward us. But the floor beneath that light is sliding backward faster than the light can run forward. Imagine a professional sprinter running on a treadmill at the gym. The sprinter represents a beam of light from a distant star, and the treadmill belt represents the expanding universe. If the runner is moving at 20 miles per hour while the machine is set to 30, the runner will never reach the console. No matter how much energy the runner spends, they are actually getting further away from the front of the machine. In the deep cosmos, billions of galaxies are currently behind this invisible wall. Their light is traveling toward Earth right now at 186,000 miles per second, but the gap between us is widening so quickly that the light will never arrive. This leads to a staggering realization about the 93 billion light-years we call the observable universe. We can see these distant galaxies today because their light started its journey billions of years ago, back when the universe was smaller and the treadmill was moving slower. But as the expansion of the universe accelerates, a discovery that earned Adam Rees and his team the Nobel Prize, the finish line is moving further away. Scientists now calculate that 94% of the galaxies we can currently see in our telescopes are already physically unreachable. Even if we built a ship that could travel at the speed of light today, we could never touch them. They are essentially ghosts. The reason this is happening is a mysterious force called dark energy. In 1998, two independent teams of astronomers were studying exploding stars to see how much the universe's expansion was slowing down. They expected gravity to be pulling everything back together, like a ball thrown into the air, eventually falling back to Earth. Instead, they found the opposite. The ball wasn't slowing down. It was screaming upward, faster and faster. Something is pushing the universe apart, acting like a constant pressure that gets stronger as more space is created. The more space there is, the more dark energy there is, and the faster the treadmill spins. To understand the scale of this, we have to look at the numbers provided by the Planck collaboration in 2018. They confirmed that the universe is not just expanding, but that the rate of expansion is remarkably consistent across the sky. This means that we are living in a unique window of time. Right now, the sky is full of stars and galaxies because the light from the early universe had enough time to reach us before the expansion became too extreme. We can still see the wall of light left over from the Big Bang, discovered by Arno Penzias and Robert Wilson in 1965. But that wall is slowly receding into the darkness. This process is not a hypothetical scenario. It is a measurable reality. Every second, about 20,000 stars cross the threshold where they become unreachable to us forever. The universe is effectively leaking. We are standing on a shrinking island of visibility in a vast, stretching ocean as the space between us and the rest of the cosmos continues to grow. The light from distant clusters will be stretched so thin that it will eventually shift out of the visible spectrum entirely. One day, billions of years from now, the redshift Slipher first saw will become so extreme that the galaxies will simply wink out. So if space is stretching and galaxies are vanishing, what does the final map of the universe actually look like? If the treadmill never stops and the expansion keeps accelerating, what happens to the stars that are left behind in our own neighborhood? We have seen how the universe pushes things away, but there is one force that refuses to let go. To find out why our own night sky hasn't disappeared yet, we have to look at the violent, Invisible war being fought between the expansion of the universe and the power of gravity. It is a battle that determines whether the Earth itself will one day be torn apart by the very space it sits on. Could we be living in a universe that is actively disappearing before our eyes? In 2016, a team of astronomers using the Hubble Space Telescope released a study that fundamentally shifted our understanding of the cosmic landscape. These researchers were not hunting for local planets. They were attempting to calculate the total number of galaxies in the observable universe. For decades, the consensus sat at 200 billion. However, when the Hubble Deep Field surveys were finalized, that figure was corrected to 2 trillion galaxies. Each one serves as a massive city of stars, housing hundreds of billions of suns. While this felt like a triumph of discovery, the math revealed a grim reality that went largely unnoticed by the public. The 2016 data confirmed a haunting statistic. 94% of the galaxies we see right now are already physically unreachable. Because the universe expands at an accelerating rate, the space between us and those distant lights grows faster than the speed of light. This is not a glitch in physics, but a hard consequence of our geometry. Even if you boarded a ship today capable of traveling at 300,000 kilometers per second, you would never arrive. You could fly for 1 trillion years and only find yourself further from your destination than when you started. Imagine trying to run toward the end of a hallway that stretches away faster than your legs can move. No matter how hard you sprint, the exit sign only grows smaller and dimmer. This is a fundamental wall built into the fabric of nature. The light from these 94% of galaxies still hits our telescopes. Yet that glow is merely an echo of the past. The actual objects have already crossed a cosmic finish line called the cosmological horizon. They have moved into a region of space forever disconnected from our own, essentially existing in a different universe while their old light drifts through our backyard. This realization stems from the work of Adam Rees and his colleagues in 1998. They were studying distant, dying stars called supernova to measure how much the universe was slowing down. They expected gravity to act as a cosmic brake. Instead, they found the expansion was screaming ahead. A force known as dark energy is pushing the universe apart like an invisible hand. By the time the 2016 Hubble study arrived, the conclusion was unavoidable. The vast majority of the sky is already gone. We are looking at a graveyard of light, watching signals from civilizations we can never interact with. To put this in perspective, consider every grain of sand on every beach on Earth. Now imagine that 94% of those grains suddenly become untouchable ghosts. You can see them, but your hand passes through nothing but empty air. Out of 2 trillion galaxies, only 6% remain within our reach. Every second that ticks by, another few thousand stars slip over the horizon. The universe is not just big, it is actively leaking away from us. The light reaches us because it was emitted billions of years ago when those galaxies were much closer. It has spent eons traveling through space to reach the mirrors of our telescopes. However, the galaxy that sent that light is no longer there. It has been pushed so far back by the expansion of space that any new light it sends today will spend eternity trying to cross a gap that grows wider every moment. We are watching a movie of history where the actors have already left the theater. This creates a lonely future for our corner of space. Scientists at Harvard and Caltech have modeled this process over billions of years. Eventually, the expansion will stretch distant light until it becomes completely invisible to any telescope. The sky will go dark. The 2 trillion galaxies we see now will vanish one by one, leaving the Milky Way and its few closest neighbors alone in a massive void. Future astronomers on a planet orbiting a distant star might look up and see nothing but blackness, never knowing a crowded universe ever existed. We are living in a unique window of time. We are late enough to have developed the technology to see the edge of the cosmos, but early enough that the light remains visible. We are the last generation of observers who can witness the full scale of these 2 trillion galaxies. In a few billion years, the ghosts will be gone. The cosmic curtains are slowly closing on a show that started 14 billion years ago. The scale of this loss is difficult to grasp. We usually think of the stars as permanent fixtures, the one thing in the world that never changes. But the Hubble Space Telescope tells us the stars are fleeing. The universe is a dynamic, stretching entity that constantly sheds its own parts. Every time you look at a faint smudge of light in the deep sky, you are likely looking at a beautiful memory of a place that no longer exists in our reality. If most of the universe is already unreachable, we must ask a deeper question about the parts we can still touch. If the distant galaxies are sprinting away, what is happening to the space inside our own galaxy? Are we truly safe in our little corner of the cosmos? Or is the same force that is pushing the universe apart starting to affect the very ground beneath our feet? The next part is the reason it matters. If the expansion is accelerating, what happens when it finally reaches us? Why would a universe evolve eyes that are incapable of seeing the whole truth? If you could travel at the speed of light and leave the Milky Way behind, you would eventually hit a barrier. This is not a physical wall of stone or glass, but a curtain of blinding, ancient light. In May 1965, Arno Penzias and Robert Wilson were working at Bell Labs in New Jersey. They were using a massive, horn-shaped antenna to listen to the stars when they encountered a persistent, annoying hiss. It sounded like the static on an old television set. The two researchers tried everything to fix it, even scrubbing out the bird droppings from the antenna to ensure the mess wasn't causing the interference. But the hiss remained. It was coming from every direction in the sky, 24 hours a day. This accidental discovery was the edge of our reality, known to scientists as the cosmic microwave background. This is the oldest light in the universe, dating back 13.8 billion years. To understand why it acts like a wall, you have to realize that the early universe was a thick, glowing fog. It was so hot and dense that light could not travel through it. You might as well have been trying to see through the center of a star. Only when the universe cooled down enough did the light break free and rush out in every direction. Today, that light has stretched and cooled into microwaves, creating a glowing curtain that marks the limit of how far we can ever see. We are trapped inside a bubble of light, and this curtain is the skin of that bubble. But here is where the floor drops out from under us. Just because we cannot see past that wall of light does not mean there is nothing there. Most scientists are convinced that what lies beyond the curtain is far more massive than everything we have ever mapped. In 1981, MIT physicist Alan Guth proposed a theory called cosmic inflation. He suggested that in the first trillionth of a second after the Big Bang, the universe did not just grow. It exploded outward at a speed that defies imagination, expanding faster than the speed of light itself. If Alan Guth is right, the universe grew so large and so quickly that the part we can see is just a microscopic fraction of the whole. How much are we missing? To put that in perspective, imagine looking at a single drop of water. If that drop represents the observable universe, everything we can see with our most powerful telescopes, then the entire ocean represents the rest. Researchers at the University of Oxford used statistical modeling to estimate the scale of this hidden realm. They concluded that the unobservable universe is likely at least 250 times larger than the part we can see. Other theories suggest it might be billions of times larger, or even infinite. We are like sailors in the middle of a vast midnight sea, able to see only as far as our small lantern reaches. The ocean continues for thousands of miles into the dark, but for us, it might as well not exist. This creates a terrifying reality for the laws of physics. If the universe is truly infinite, then everything that can happen must happen. In an infinite space, the arrangement of atoms will eventually repeat itself. This means that somewhere out there, beyond the wall of light, there could be another version of our galaxy, another version of our solar system, and another version of you. It sounds like science fiction, but it is a mathematical consequence of a universe that never ends. Scientists still can't fully explain why the universe is so flat and uniform. The leading theory is that we are simply seeing a tiny, smooth patch of a much larger and more chaotic structure. Because space is expanding, that wall of light is actually moving away from us. Every second, more galaxies are slipping over the horizon and into the unobservable dark. We are losing pieces of the universe forever. It is like a library where the books on the far shelves are slowly catching fire and turning to ash. Eventually, in the distant future, every galaxy beyond our local neighborhood will have moved so far away that their light will never reach us again. Future astronomers on Earth would look up at a sky that appears completely empty, unaware that billions of other galaxies ever existed. We often think of nothing as just empty space. But in the deep cosmos, space itself is a physical thing that can stretch, bend, and grow. This growth is being driven by a mysterious force we call dark energy. In 1998, Adam Rees and his team discovered that the expansion of the universe isn't slowing down as everyone expected. It is accelerating. The universe is pushing itself apart faster and faster every day. This means the unobservable part of the universe isn't just a mystery. It is a graveyard. It is a place where information goes to die, locked away behind a speed limit that even light cannot break. What happens to the physics of a world that is essentially invisible? If the vast majority of the universe is hidden from us, can we ever truly claim to understand how the cosmos works? We are building our laws of gravity and time based on a 1% sample size. It's like trying to understand the plot of a 1,000-page novel by reading only the first sentence. The more we learn, the more we realize that our observable bubble is a tiny island of light in a sea of infinite darkness. We are reaching the limits of what human beings can ever know through observation alone. To truly grasp the scale, you have to accept a lonely truth. We are not at the center of the universe. We are just at the center of our own perspective. Every star we see is a ghost, and every distance we measure is a reminder of how much we are missing. The wall of cold fire, the cosmic microwave background, is a finish line for our eyes. It tells us that the universe has a beginning and a limit. But it also hints at a reality so large that our minds are simply not equipped to hold it. The question that haunts astronomers today isn't just about what is out there, but what happens when the lights finally go out. If the expansion continues and the unobservable universe swallows everything we know, what remains? We are living in a brief window of cosmic history where the sky is still full of clues. But the clock is ticking, and the horizon is closing in. This leads us to the final, most unsettling question of all. If the universe is expanding into the dark, where exactly is it going? Will the golden age of light last forever? Right now, the sky remains a crowded tapestry of ancient histories where the glow of 2 trillion galaxies is still close enough to reach our eyes. This cosmic abundance is a temporary gift. Because space is stretching, the light from those distant islands of stars is being pulled like a piece of chewing gum. It grows longer, redder, and weaker with every passing second. Eventually, that light will be stretched so thin that it will simply stop existing as something we can see. The universe is expanding into an increasing emptiness. We are witnessing a slow-motion vanishing act that began billions of years before we were born and will continue long after our sun has gone cold. What does this mean for the people of the deep future? Imagine a civilization living on a planet orbiting a star in our galaxy 100 billion years from today. When their astronomers build their first telescopes and point them at the void, they will see something fundamentally different from what we see tonight. They will find the Milky Way and a few nearby neighbors that gravity has managed to hold onto. But beyond that, they will find nothing. The great cosmic web of galaxies we study today will have been pushed beyond the horizon of the observable universe. To those future observers, the universe will look like a small, lonely island in an infinite, black ocean. They will grow up in a world of total darkness, believing their galaxy is the only thing that has ever existed. This is the strange reality of the great loneliness. In 1998, Adam Rees and his colleagues discovered that the expansion of the universe is accelerating. The exit doors are closing faster and faster. If we had evolved just a few dozen billion years later, we would have no way of knowing the Big Bang ever happened. We would have no cosmic microwave background to detect, no distant supernova to measure, and no evidence of other galaxies to spark our curiosity. All the clues we use to understand our origins would be gone, erased by the very fabric of space itself. We exist in a rare window of time where the universe is still telling us its secrets. You can feel the scale of this loss by looking at how we spend our time and resources. Astronomers at institutions like Johns Hopkins and the Space Telescope Science Institute are currently racing to map as much of the deep sky as possible. They are building a library for a history that is literally disappearing. Every time a new telescope like the James Webb launches, it represents a desperate attempt to capture the light of galaxies currently crossing the point of no return. Once they cross that line, no amount of technology or physics can ever bring their information back to us. We are the last generation of humans who will see the universe in its full, crowded glory. How do you live with the knowledge that 94% of what you see is already unreachable? You start by changing how you look at the night sky. The next time you find yourself away from city lights, look for the faint, fuzzy patch of the Andromeda Galaxy. It is the most distant object a human being can see with the naked eye. Realize that you are looking 2.5 million years into the past. Most of the light from the rest of the universe will never make that journey. It is a reminder to appreciate the view while we have it. The stars are a fading record of a much larger story that is slowly being pulled out of reach. Scientists often call this the end of cosmology. The universe will eventually hide its own past so perfectly that no scientist, no matter how brilliant, will be able to deduce the truth. This should give us a profound sense of urgency. We are the detectives arriving at a crime scene where the evidence is being burned in real time. This reality pushes us to look deeper, to ask harder questions, and to cherish the data we have. It turns the act of looking through a lens into an act of preservation. We are the witnesses for trillions of stars that will one day vanish into the dark. If you want to feel this connection yourself, you do not need a multi-billion-dollar satellite. You can track the movement of our own local neighborhood by using simple stargazing apps to find the great attractor. The region of space our galaxy is currently screaming toward at 1.4 million miles per hour. While the rest of the universe flies away, we are huddling together with our closest neighbors for warmth. Watch how the moon rises and sets, and remember that even it is slowly drifting away from Earth at about 1.5 inches per year. Everything in the cosmos is in motion, and most of that motion is a long, permanent goodbye. The numbers of the universe are so large, they usually make us feel small and insignificant. The great loneliness suggests the opposite. If we are among the few beings who will ever get to see the true scale of the cosmos before the lights go out, then our observations matter deeply. We are the memory keepers of the universe. Our math, our photographs, and our wonder are the only things that will remain of those distant galaxies once their light finally fails to reach our corner of space. We are the eyes of a universe that is slowly going blind. Think back to that image of standing in your backyard, looking up at the silence. It feels permanent. It feels like those stars have always been there and always will be. But now you know the truth. The sky is a leaking bucket. Every second, a volume of space the size of our galaxy is being pushed beyond our reach forever. The universe is a vast, beautiful, and temporary light show, and we have the best seats in the house. The darkness is coming, but for now, the sky is still full. The vastness of what remains is a reminder that our time to wonder is a rare and fleeting gift. Subscribe, a new breakdown like this every day.